Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 25 of our main LeetCode challenge, and the problem that I'm given to us today is the uncrossed lines problem. Again, if you want to try solving this problem on your own, you can pause this video and check out the LeetCode link given in the description below, and let's get started. So the problem statement is that we write the integers of a and b on two separate horizontal lines. So there's an example with a good depiction that you can sort of look at where you've been passed two values a and b which are coming in the form of a list, and you just write them down. Now we may draw connecting lines, and the rule for connecting lines is that ai should always be equal to bj, and the line that we are drawing should not intersect any other connecting line. So intuitively, if you look at this example, what you're basically doing is you're doing something like a match the following sort of an example, where whenever you have the same values, you sort of match it up. So if you go one by one through all these values, you can sort of look at this thing where you have 1 and you just map that out. Then you look at 4, you map that out with the last element inside the second list, and then you don't really map 2 with this 2. That's because of the second constraint which has been given to us, which is that no intersections are allowed. And eventually what you want to do is you want to return the maximum number of connecting lines that we can draw in this way. So there are a few more examples that you can sort of draw it out and sort of go through them on your own. But whenever you have certain problems like this, the first few questions that you would want to ask is, hey, is the length of A always going to be equal to the length of B? In which case, you will sort of get an intuition of how you would want to try solving this problem. Now you can solve this problem using recursion because there is no set constraint given over here that the length of A should always be equal to the length of B. Also, you might want to perform a lot more combinations just to understand whether things are going to get matched up correctly. So finding the max is going to be a little difficult unless you perform some memoization on top of it. And this problem has a lot of semblance to a similar dynamic programming problem, which is actually a very famous problem called as the edit distance problem. We've solved a similar problem like that before, but intuitively what's going to happen is that if you have the same value, or whichever value that you're presently at, if you find the same value, what you would want to do is you'd want to increment the counter at a particular max level, and then you would sort of move forward from there. So I've drawn a quick example over here. So we have this 142 and we have this 124. So 124 is going to be represented as our row indexes, and 142 is going to be our column indexes. So essentially, if you sort of go through each value, what you would want to do is you would want to update each value as sort of as you're going forward. Now do note over here, I've put a slash over here at the very end, and that's just because I'm going to be doing, I'm using a top-down approach. You can also use a bottom-up approach, whatever you're comfortable with. But just for the example, I think it's a lot more better if you use it. So whenever you have the same value, so let's say you're iterating through each value for each row. So you go from each row to each column. So what's going to happen is that this is going to be your first iteration. So when you're going through all the columns inside your first row, what you're going to be doing is you're going to be comparing one with this one. Whenever you have a match, what we want to do in that case is that we want to update the value and we want to increment it. Now, there are two ways of actually incrementing it. Either you can increment it at this index or you can increment it at this index. It's just a matter of how you're following up with the bottom up or the top down approach. But essentially what's going to happen is that this thing is going to become 1. And then there's going to be no other matches over here, so there's nothing else which is going to get updated. Then when you go to the second row, what you're going to find is that this particular guy that we're presently at is going to have the perfect match that we're sort of looking for. When that match happens, you would sort of update the value as we sort of talked about before. And what's going to happen apart from that is also whenever there is no match, that is when you don't find anything, you're going to update that value as well. So this is like a pretty fairly decent problem where you just use dynamic programming and you keep on updating the indexes as you're sort of moving forward. But once you draw it out, what you're going to essentially get is at the last value, you're going to get the maximum that you can encounter. So let's just start with our implementation, and we always start with our base condition, which is not if nothing's been given to us, then we return a 0. I'm also going to create something called as n1 and n2, which we can just leverage, which is just going to be equal to the length of a and length of b. Now, the next thing that I want to do is I want to create my DP 2D matrix, and I want to fill it up with nothing but zeros. So that's also pretty straightforward. So let me just quickly do that. And again, I'm sort of using list comprehensions here just so that I can do this in one line. So when I have something like this, all I want to do is I want to iterate through each of those values. And while I'm doing the iteration, I just want to make sure that I'm checking for the correct things. So assume for I in range of n1, which is the number of rows, versus n2, which is going to be our number of columns. What we want to do is we just want to check for whether the dynamic programming matrix that we have so far, whoops, sorry, the parameters that have been given to us, whether they are equivalent. So if AI is equal to bj, what we want to do is we want to increment the counter as I mentioned before. So again, it's the same paradigm as the edit distance problem. So you just say, hey, if this is the case, then whatever's the next value, I'm just going to upgrade it. So I'm just going to update it with whatever's already existing at dpij because it's a perfect match, and just increment that value. Otherwise, if there is no match, then I'm going to upgrade this guy dpi plus 1 and dpi plus 1 and j plus 1 to whatever's the maximum on the top versus whatever's the maximum on the left. Basically a simple comparison between top um, and, and bottom. So that's pretty straightforward. You just do dpi plus 1 or you do dpi j plus 1. So basically you're looking for those values which are already existing inside your present DPI. So if you look at the previous example, which I was sort of talking about, essentially what's going to happen is that you're just looking for the values which is on top versus which is on the left, and then sort of updating the values. It's a little tricky for most people to understand. It really depends on the preference of a person, to be honest. You could also do dpij and just check the last value and update that for all other values as well. It's really just a matter of preference, to be honest with you. I feel like for me, it's a lot more easier this way. So that's just something that I use. And eventually what you want to do is you just want to return the last value which you have. So um, this should basically do it. So again, all we're doing is we're just maintaining a count, and as we're sort of moving forward, that count is going to get updated whenever it's going to have AI and BJ corresponding to each other. Now, the way you sort of like take care of cross lines coming together is just that cross lines would never happen in that case unless and until, I mean, basically you're just trying to find out the maximum that you get so far. So if you have a lot of cross sections which are going through one particular path, the other path would probably have the maximum. That's enough talking for me. Let's just go ahead and run this, and hopefully this should run fine. Unfortunately, I'm getting an error, so let me just quickly check that. DPI. Oh, yeah, that makes sense. So since I'm expecting it to run till that value, I think I need to do this so that I have the right values. And I'm not getting index out of bounds. And I can see that the expected answer is the same as the answer that we're providing. And let's just go ahead and submit this. And hopefully this should run fine. Cool, you can see that's been accepted. And again, this problem in all is actually really simple. You just need to like apply the edit distance formulation to just solve it. And there are multiple ways of solving it. I'm going to post the link to the YouTube video where I explain the edit distance formulation. But overall, this is a pretty straightforward dynamic programming problem. Cool. So that was it for today's video. If there's something that you didn't understand, do leave it in the comment section below, and I'll try to get back to you as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. Thank you and have an awesome day.